Hey guys, Mr. Marone here. Welcome back in. So last lesson we looked at similarity and how we could prove triangles similar, and we had three methods for doing that. We had angle, we had side similarity, and we had side similarity. Now we're going to focus in and look at similarity in right triangles. So before we get to that, there's a concept up at the very top that I've already filled in for you if you want to take the time to fill it in. But we're going to talk about these ideas of an altitude. If you were to draw a perpendicular segment down from any vertex of a triangle to its opposite side, you create an altitude, and it creates a couple other triangles within a triangle. If we do that in a right triangle, if we start at the right angle like you're seeing down here, and drop straight down to the hypotenuse, we actually form three similar triangles. And I'm going to do a quick proof of that as we go. What I'm going to do is draw out my three triangles. If you notice, we still have the big triangle, ABC. We have this left-hand triangle here, triangle ABD or ADB, and then we have this triangle here on the right, this littlest one. So I'm going to draw all three so that they're in the same setup as this little guy right here. So in other words, if I were to draw BDC down here, there's D, there's B, and there's C, and there's my right angle. I'm going to draw the other two so that they're in that same orientation. So my big triangle, drawn that way, is going to have angle A up here, angle B right here, and angle C right there. And then my medium-sized triangle, the left-hand one, drawn like that, is going to have A at the top, it's going to have D down here, and it's going to have B right there. And so if we look closely at this, we know, thinking about angle, we only need to have two sets of congruent angles. All three of these have a right angle here, so that's one set that are congruent. And then if we look closely, the big triangle and our left-hand triangle both have angle A, this one that's shared down here. So we can mark that as shared, and that tells me that the big triangle, ABC, and the left-hand triangle, ADB, are going to be similar by angle. Okay, they both have that shared angle A. And then if we look at the big triangle and my right-hand triangle, they both share angle C. So this angle here and this angle here are going to be congruent, so we have similarity there as well, all by angle. And so what it allows us to do, if we think back on similarity in triangles, the angles will be congruent and the sides will be proportional. So if we compare these triangles, if we compare ADB, the left-hand triangle, to BDC, the right-hand triangle, looking at these, noticing here that they both have angle B, these little two triangles are going to be similar as well. So if we compare them, side AD compares to BD. We can also compare DB to DC because of the orientation, and we can compare AB to BC, and all three of those are going to be proportional. Now if we compare ADB to ABC, we compare the left triangle to the big one, we've got AD over AB. We then have, if we compare the hypotenuses, we've got AB over AC, and then if we compare the two bases, you've got DB over BC. So those are comparing those two. And then if I compare my littlest triangle with my big triangle, I've got AB. I'm sorry, we're gonna reverse that. We're gonna compare the little one to the big one. I've got BD over AB, and then comparing the hypotenuses, I've got BC over AC, and then comparing the bases, I've got DC over BC. So what we end up having here, if we look closely at these, is we end up having this idea of a geometric mean. And that's when we compare two numbers and the number x, and it satisfies this setup here. So if you look closely, you've got two numbers a and b, and then you've got x times x. So you've got this same relationship, top and bottom. And if we look closely at all three of ours, we have that setup. You've got a BD down at the bottom and a BD right here for that one. You've got AB and AB, and you've got BC and BC. So all three of these have a geometric mean in them. Before we try to use triangles, we're going to just try the geometric mean first. So I'm going to show you the first one and let you guys try the next two. So if I'm doing the geometric mean of 3 and 6, that means I'm just going to plug 3 and 6 in for A and B, and then let x be x. So I'd have 3 over x equals x over 6. And when I cross multiply, I have x squared equals 18. And when I take the square root of that, x is going to be equal to 3 radical 2 when I simplify it. Okay, if you need a quick remembrance, 18 can be broken into square root 9, square root 2, and that's 3. So go ahead and try doing the geometric mean for 4 and 8 and for 10 and 2, and when you come back in, those answers will be right there for you. All right, welcome back in. So we've got 4 radical 2 for our first one, for the geometric mean of 4 and 8, and we've got 2 radical 5 for our other one, for 10 and 2. Now, if you notice, with 3 and 6 as well, all 3 of these required you to simplify radicals. So just keep in mind that you're probably going to have to simplify some radicals. Now, we're going to flip back and forth, so when we do these, I encourage you to do that as well. I'm going to use this chart right here as we go to try to apply these when it comes to triangles and right triangles. So just a reminder, we're looking for a way to use those shared sides. So here's what I mean. If we look at this first example, I'm going to do this one up here, and then we can do this other one over here. They take a little bit of space. We're going to look at these. So they gave me, in my left-hand triangle, they gave me the 2 legs. And in my right-hand triangle, they gave me the 2 legs. So what we're going to try to do is set up a comparison here. If we go back to our comparison of our 2 little ones, we said that AD, if we wanted to label this one, we could label this A, B, C, and D. So I've got ADB and I've got BDC. And if we look closely at our ADB and BDC, we said it was AD over BD. So I've got AD over BD, which is 6 over X. And then we also said we had DB over DC. So DB X over DC 8. And if you notice, we've now set up a geometric mean. We can then solve this to find x. We can cross multiply, and we have x squared equals 48. And when I take my square root of that, I can break up 48 into 16 and 3. So x is going to give me 4 radical 3. So this value goes right there. Your ultimate goal is to set up something that works like this. When we get to this one over here, where there's 3 missing pieces, we're going to set up our 3 means. The thing is that we're going to have to do them in a very specific order. Okay, so what I'm going to do personally is I'm going to redraw this picture with 3 triangles already laid out in the form that we did right here, so that it's easier for us to compare the drawings. So if we do that, I'm going to have my left-hand triangle here is going to be 5 is going to be 5z and x. I'm then going to draw the medium one, which has x, y, and 15. And then I'm going to draw the biggest one. And that one has z. 5 plus 15 is my hypotenuse, so my hypotenuse is 20. And then I've got y for my other leg there. So now that I've got these set up properly, we can do a comparison here. If you look closely at my middle one and my big one, they both have a number and a y at hypotenuse and that left-hand leg. So I can set up y over 15, my left-hand side, equals 20 over y. And once we have y, then we can set up some of these other ones. If we really wanted to, we could set up the other ones as well. But like we could set up z as well. 5z, 20, and z. So I could set up that 5 over z equals z over 20. And then I just have to figure out x once we have the other values. If we wanted to, we could do them right here as well. We could do x over 15 equals 5 over x. So by breaking this apart and knowing these relationships right here, it gives us the ability to set up 3 geometric means. This looks horrible and this looks terrible to solve, but all 3 of these are very simple. They're just like this. I'm going to let you guys go ahead and solve those 3 and write down your answers for X, Y, and Z. And when you come back in, the answers will be there for you. All right, welcome back in. So I've done all the work down here, and then I put all my answers up here on the right. I ended up with X and Y both having a radical 3 attached to them, 5 radical 3 and 10 radical 3. And then I got 10 for Z. This is going to be pretty common for you to have one whole number and then a couple with radicals as well. This is something we're going to stay with for a couple days. You've got like 4 days of practice and time to watch these videos, so don't panic. These are very, very difficult. This is probably one of the most difficult topics that you'll see in geometry. So take heart if you're concerned about the difficulty level, because it's hard, and that's why we're here to help you walk through it. They're not impossible, but they are just something you're going to have to work a little bit on. So just wanted you to be encouraged that, like, if this doesn't make sense, that's okay. That's very normal. You'd be a little weird if you're like, oh yeah, this makes perfect sense right away. So keep that in mind as you bring in questions, and I look forward to seeing you guys tomorrow. Have a great day. Bye-bye.